Okay, so you should have been able to do all those steps and find out if there was mediation. You can read more on the page I've sent you, and then that will also tell you how to do it in SPSS if for some reason you ever have to do it in SPSS. That has some links for it as well. So, now what we want to do is, so we've established the steps, so people usually want to find out if that is significant or not, because we care about p-values, and that's why. So what that is typically done is we use the both paths at the top, so from x to m and from m to y, to test whether that product is significant. So if you multiply those, if that's significant or not, and that was basically the same as seeing if that drop you get from controlling, if that is a significant drop, and that's how we get that. So older models use the Sobel tests, and I'm going to teach you the Sobel test, and also Barron and Kenny is sort of 1986, like an older model, but you should be aware of this. So the Sobel test is also known as these product methods, and so basically it's multiplying these two type things. You can read more about it on the link I put in, and there are also alternatives, which are basically corrections for the Sobel tests. There's some debate on which one is the best one. Usually, if you have a very large sample, all the conclusions will be the same. It doesn't matter too much which one you pick, whether it's Sobel or Royan or Goodman. They're all different. They change a little bit in terms of degrees of freedom or in terms of parsing out some things. But the most novel, one of the more recent recommendations is to basically use bootstrapping. We've done bootstrapping before to find out if that is significant, because the problem is that the Sobel test requires quite a large sample size, and often in psychology you might not have a very large sample size, and so that's why the Preacher and Hayes method relies on basically calculating whether that path is significant via bootstrap methods rather than using a single z-score. Okay. In order to do the Sobel test, we use the BDA package, and as you'll find out, sometimes R and R Markdown is forgetful, and so you have to load things within the chunks again. So here I reloaded the data just to make sure that it again remembers it. And the code itself is very simple. It's mediation.test, and then we first list the mediator. That's with the $sign. So you remember that the $sign is to call the variable you want to use in your formula, and so this is data underscore met $m, data met underscore $x, and then data met underscore y. So mediator independent dependent. Yeah, that's the structure, and then it will print you the Sobel test, and so you can see that this is significant p-value. And so the E is for moving the decimals to the thing. So it would be 5. You would have to move it 5 times. So it's highly significant. You don't get star notation here. And so the E plus 0, 0 means don't move to the decimal. So this would be just 4.327, that value. In this case, it really doesn't matter too much if we picked Sobel or Royan or Goodman. They're all significant in all similar type of values, so we draw the same conclusion. There might be cases where it differs, and it's good to think about if it's just borderline, then perhaps nothing really is going on, and you should proceed with caution. Yeah. So that's a very easy way to do this Sobel test. And what you would write in your report is a Sobel z-test showed that the mediation effect reported in figure X. So you draw that figure was significant. And unfortunately, my HTML doesn't italicize, but z-scores should be in italic. So you should know from the APA, certain things are put in italic, but occasionally, sometimes my slides will not do that because you can't do it. So also the P would be italicized in your. So all those things, if you do the exercises, you'll have examples where it is correctly italicized, but for this one, it might not always be italicized correctly. Any questions? So that's basically you. So what you would put in your report is that nice little figure, and then you put in a description of the Sobel z-test. And so there's 3 measures that were printed. There's slight difference in the calculation. Some people recommend Royan. I'm largely indifferent. I've always used Sobel. In my opinion, if you have large enough samples, it doesn't really change. But if there are some issues. So the downside of this is that it only works well in large samples. There's debate as to what large is. Is it 100? Some people say it's 100. Some people say it's 200. So the Sobel z-test isn't problematic if you have very large samples, but sometimes in psychology you have very small samples. You will only have 30 participants or 40 or a small number, and then you're better off using the bootstrapping method, which I'll show to you later. And so that's bootstrapping to the rescue, and so throwing lots of things. And so that's also why I've been talking to you about bootstrapping before, because it has some really nice properties. So with bootstrapping, we really try to infer the uncertainty from our own data. So we basically draw repeated samples from our own data over and over again, and then evaluate a statistic. That's all there is to it. So now we're going to try to do this bootstrapping approach. We use a different package, a package appropriately called psych for psychology. It's also a package we'll use later for factor analysis. And unfortunately, the beamer is flashing. I'm not sure if you see that, but it's we need a new beamer. So I've called it mediation model 1, and then I assign an arrow, and then the description is mediate. And note here that this is different than the BDA package. So here, the dependent variable goes first, then the independent variable, and then M, and then you say which one you want as a mediator. I use the C notation here because it's a vector, and you can have multiple mediators. And that's why I use the C to basically string them together, because now we've just had a very basic model with one mediator, but in principle, we could have many different mediators or many different causal paths. So that's why there's a C there, and then the list of the variables that will be chained together as mediators. STD is not for sexual diseases, for standardization. So it's basically that we want betas rather than Bs. So that's to do that. We tell it where the data is, and we tell it the number of bootstraps we want to do, and be aware it will take time also for your assignments. Don't worry too much. Sometimes it will go crazy. Your computer will have to do some computations. That's what you're paying Windows for or Mac to basically get lots of computations going, and there's no reason why I can't calculate it 10,000 times. And in this case, I've just said that the plot should be false, but I'll show you a plot later. Yeah? So what I've done here is, you can see it starts printing all sorts of output, which doesn't fit on my screen. So what I've done here is I've installed a sync. Basically, what it does, a sync, it says, put all the output from that into a text file, so we can look at it later without printing it all to my thing. So this is what that, and so we'll be going to your working directory. And so basically, anything between the sync will go to the sync, and the sync is that text file. So what I'll do is I'll open the text file, because this is unformatted and it's just a whole load of file printing. So I'll open that now so you can sort of see what it prints. Yeah, so for some things, it might be useful for you to put it away into an output file, and then look at it separately, and then change that or do anything with that. So use a sync for that case. And this will go to your working directory. So let's see if I can find it. So mediation.txt, so that's the sync I made, and it will have not done that because it will have overridden it. So what I'll do is I'll just rerun that chunk here. It's because I just rerun my thing here, so I'll rerun this chunk, and then we'll go here. So this is the back end of the slides, and it's also what I upload there. So it's running all the analysis, and then it will send it to the sync. It should send it to the sync. We'll send it somewhere else. I have to set the working directory. So I haven't set a working directory, which is why it's not going to that. There we go. So what is printed here is what this has done. So once you do that, and now in my case, because I didn't set a working directory, it will have stored it somewhere else. But it will have printed a whole host of outputs, and then we can work our way through that output. It will have the formula of the thing which we did. So that should be y is the dependent, x is the independent, m is the mediator, the data, the iterations, and standardization. It will tell you what the total direct effect is. So that's basically the sum of the direct and the indirect effect with some probability. And so that's C prime. This would be if you remove the mediator, how much of it is left. So it goes from 0.34 to 0.03. So that's the 0.72 that was dropping out of significance. Remember when I was showing it to you before, if we controlled for the mediator, it sort of dropped out of significance, and that's basically telling us the same as we saw with the Barron and Kenny causal steps approach. Yeah. Then with the indirect effect is the thing we care about most. This is this A type B part multiplication, and that basically this plus that should roughly sum to that. Yeah. So it's so basically how much it's basically telling us how much of the variance or how much of the thing is explained via the mediator, how much is going via that top path after we control for it. And what we can then do, so that's the bootstrapped effect, so that's just the estimates as we can get from just multiplying the coefficients, but we can also bootstrap it. It has a standard error to it, and it has a 95% confidence interval to it. And then this is the R-score of the model. And so you can get an even longer output, but this is basically then also putting it sort of with significance tests, the total effect, the direct effect estimates, X and M, the A path, the B path. So that's those type of things. And this is the one we care most about, and we want this to not overlap with 0. That's basically the bootstrapped top half. So remember, X via M to Y. So it's basically that multiplication, whether that's significant or not. And so we want that confidence interval not to overlap with 0, because that would show that it's significantly different from 0, and that would show that we have significant mediation, that path really matters. Any questions? So we'll print lots of output. Some of it is repetition, so the same values you see appearing, but that's basically would allow you to complete that chart. And basically, we care most about this, and so that would be the 10,000 bootstraps. That's the 90%. That's the 95% confidence interval on that. So it goes from 0.19 to 0.43, and those are betas because we standardized everything. So that's comfortably different from 0, right? Does everybody understand? Because I might be going slightly too fast. So I didn't print that all on a slide because you can see it's quite a lot of output. So your R will also go berserk and print this entire text string when you do it. Okay. Back to the slides. So you can see the beginning of it here, but then it sort of fell off. So if you would write it up, you would say a mediation model with 10,000 bootstraps indicated the indirect path was significant, and that's basically that A times B path. That was the last thing I showed you before. And so this is the beta. So because we standardized everything, beta was 0.3. The standard error was 0.06. You can occasionally not report standard error because people can sort of estimate what it will be if they have the 95% confidence interval, and that's the 95% confidence interval. Now, because I didn't set a seed, occasionally it might vary because bootstraps are truly random. So depending on rounding errors, you might get a slightly different number, but it will be close to the 0.0. I think I put 0.09, and so it's rounded up or rounded down depending on the decimals. Yeah. And you could still add in your methods, write up which package produces it. So you could say mediation analysis via the psych package in R version X using 10,000 bootstraps showed that there was a significant mediation and the indirect path was significant, the beta, and then the 95% confidence interval for beta. Yeah? Does everybody understand sort of the write-up? And that's also what you will read in most, at least this is quite popular in social psychology. It might be popular in clinical psychology, but this is what you'll read in most reports. So, not wholly visible, but you can get a diagram out of it. So rather than you drawing all the arrows yourself, which you can do via diagrammer, you can also ask it to print it. It's printed quite here in low resolution, but I'll see if I can show you in a bit. So what it did here is tell it to send it as PostScript, but you can also ask it to print a PDF of some sort. But PostScript, if you're on a Mac, is quite comfortable because it will change into PDF just by clicking on it. So here I say set APS. This is what I want the file to be called. I want it to be not a horizontal file. I want it to be not to insert breaks. I want it to use special papers. There's all sorts of other settings you can pick. And this is basically how much margin you want on every single side of the figure. And so that's the parameters for the margins. And then I tell it that it should take the mediate.diagram from mediate, and then def off is, so it sends it to be printed rather than sending it as output to your screen. That's why we use the def.off command. Yeah. So again, you can find out more about those commands by just reading about them, but that's a way of exporting a figure from the mediate package. So just to give you an idea, you might not be able to see it all on the screen, but this is sort of what it looks like. Yeah. So we'll have printed the A path, the B path, and then this is the path before we start controlling for the mediator, and then you can see C prime is the reduction, so it drops from 0.34 to 0.03. Yeah. Any questions? So basically, you could still toy around with it, create better labels, remove some of the white space because now it has quite a lot of white space. You can make it prettier, but that's basically what people report. They report this type of chart, and then they report this Preacher and Hayes type of bootstrapping test. Okay. Now I would like you to try it yourself, and I want you to do either or. So either do the Sobel Z test, or do the mediation. You don't have to do the diagram for the dataset that you have. So you've done the causal steps by Barron and Kearney, and now do the mediation analysis, and it will print some output. You don't have to store the output. So either use the psych package or use the BDA package to do a Sobel Z test.